She's smiling.
All right, so they have done the area model for us, okay? And so what we've got to do is we've got to add up all the units inside the area model, and then we're going to solve it by just using multiplication also, okay? So the area of a rectangle with mixed numbers as side lengths, okay? That's what we're doing. So the first length is 2 3/4. You should be writing. The second length is 1 1/2. Okay? Now, usually when I do this area model, I don't put the units, the square units inside of it, because I feel like it gets too jumbled up and we can't read the numbers as easily. But the goal here is to figure out of all these 4 boxes, what can we add in our heads? And what are we going to need to add on paper? Well, I know I can add a little bit. What can I add?
2 and the 1.
So that's 3. Go ahead and write that down. And then I'm going to have to add 3/4 plus 3/8. Now, this is taking a walk down memory lane. Okay? So, walk down memory lane, when I add fractions with unlike denominators, what do I have to do?
Find an like denominator.
Okay, so I've got to find like denominators. So you're going to write this down. What's our denominator?
8.
8. Boy, that didn't take you long. Good job. So which one of these fractions can I keep exactly the same? 3/8. And when I change the other one, 4 times what equals 8?
2.
So 3 times 2 equals 6. Okay? Now I add that all together.
You get 9/8.
So I've got 3 and 9/8. Or 4 and 1/8. Because we don't want to leave an improper fraction as the answer. Now, does everyone understand how we got 4 and 1/8?
Yes.
This would be 8/8 plus 1/8. Okay? All right. So that's using the area model. Go ahead and make sure you've got all that written down. And now we're going to solve it numerically. Oh, well, here's another thing. When I write this down, I should probably put square units there. And then I'm going to write 4 and 1/8 here because I'm pretty sure I did it right. If we get something different when we solve it numerically, then we'll adjust. Okay, don't work ahead, please. Okay, so eyes up here. This is important. Eyes up here. 2 times 4
8.
plus 3.
11.
So 11/8, no, 11/4, sorry. Times 2 times 1
2.
plus 1 more
3.
times 3/2. So when I multiply, straight across. So 11 times 3
33.
and 4 times 2.
8.
Now don't say any answers yet. I want to give everybody a chance to think. We've got to change this to a mixed number. So you could literally skip count by 8s till you get close to 33. Or you could just know your facts. Kyle, how many times does 8 go into 33?
4.
4 times. What's 8 times 4? 32. And so how many are left over here?
1/8.
Is that what we got before?
Yes.
Awesome. Okay, how we doing?
Good.
So we're going to solve it each of them 2 ways, and then you're going to do the exit ticket each of them 2 ways. Okay? So let's look at rectangle B. I'm going to make an area model, but I'm going to leave room on top and bottom for numbers. Okay? So this one's a little different, guys, and it should be easier. Do you have a pencil that works? Does your pencil work? Okay. So I've got 2 1/2 by 3/4. Where did I find that? It's right here. So I'm going to draw a line there. Dusty, pay careful attention here. I don't need a line going horizontal because I don't have a mixed number. It's just a fraction. Okay, so 3/4 times 2.
6/4.
6/4. Now I want to show you, okay? Let me show a visual. So 6/4, can we please memorize what that is as a mixed number?
1.5.
Okay, so Aaron just changed the 2/4 to a half, okay? So whenever we have 6/4, it's 1.5. Okay, now 3/4 times a half. I'm going to write it up here so we can multiply straight across. 1 times 3, 2 times 4.
8.
So what do we have to add together?
1.5 and 3/8.
Okay, so I'm going to add a 1 to my answer. You with me?
Yep.
You with me?
Yeah.
Okay, so I've got 1 plus, and then I've got to find a common denominator for 2 and 8.
8.
Same as before.
Yes.
So I'll keep the 3/8. 2 times what?
4.
So 1 times 4.
Is 4.
And that makes sense. 1/2 equals 4/8. Okay? So this one's pretty simple, actually. So I've got 1, and then I got 4/8 plus 3/8. So what's my answer?
2 and 1/8. Oh wait,
Huh?
1 and 7/8.
And that's square units. Okay, how we doing?
Good.
Now what I want to know is if you're struggling as we go. Because in block 3, I had kids come up when they were doing the exit ticket and they were just completely confused. So I need to know as we go. Okay? So now that I've got that done, I'm going to solve it numerically. Okay? So 2 times 2 is what?
4.
Plus 1 more.
5.
So 5/2 times 3/4. Okay, so what do I do here?
Multiply straight across.
Multiply straight across. 15/8. All right, now I'm going to change this to a mixed number. Hopefully it's going to be 1 and 7/8. Is it?
8 and 7/8.
Yep, it sure is. Uh-huh. And don't forget square units, please. Okay, how's it going?
Great.
Not bad. Okay. There are times when it's easier to just multiply. There are times when, and I'm going to show you one of those times on the back page, it's easier to do the area model. So you'll get good at figuring out which way you should do it. Okay, so rectangle C, let's look at it. This kind of area model is the kind I showed you yesterday. Okay, so this is 3 1/3 times 2 1/2. Go ahead and write that down. And you know, I don't make them to scale because I like to have enough room in the box to write my answer. But it's totally up to you. There's somebody here right here beside me that's got the most beautiful drawing ever. Okay? All right. So 2 times 3 is what?
6.
What's 2 times 1/3?
2/3.
So you know what I think of in my mind sometimes? I think of 2 copies of 1/3. And I just visualize 2 of them right beside each other. And that's sometimes easier. Or remember, you're going to take the whole number times the numerator. So 1/2 times 3,
3/2.
which is
1 and 1.5.
1 1/2. And 1/2 times 1/3.
1/6.
Okay. So is there anything we can add in our heads before we start? We've got to add these 4 boxes together. That's the area model. What can I add in my head, Henry? 6
plus.
Okay, so I'm going to add 7 to my answer. Okay? And then I'm going to add 2/3 plus 1/2 plus 1/6. And boys and girls, this is good practice for you because it's helping us remember how to find common denominators. You agree?
Yeah.
We've got about 2 weeks till our Kansas assessment. Okay, she thinks it's 6. She thinks 6 is our common denominator.
Yeah.
You guys agree?
Yep.
Okay, so 6. And which fraction is going to stay the same? 1/6. Okay? I'm going to go down just a little bit. All right, so 3 times what equals 6?
2.
So 2 times 2.
4.
Okay. And 2 times what equals 6?
3.
All right. So that's going to be
8/6.
okay. So it's going to be 7 plus 8/6.
8 and 2/6.
Okay, let me see if you're right. This is 1 whole plus 2/6. So you're saying 8 and 2/6.
Yes.
Only there's something wrong with that.
It could be 1/3.
It could be 1/3. Very good. So if you know to simplify it, what would you divide it by?
2.
So it's going to be 8 and 1/3. Good one, Henry. Okay. So now we're going to solve that numerically. We think it's 8 1/3. That was a lot of adding, though. Wonder if the other way is going to be any easier. You think so? Okay. So tell me what to do here. I got to change.
3 times 3.
I got to change it to an improper fraction. So 3 times 3 plus 1.
10.
So 10/3 times.
2 times 2
Okay.
plus 1.
5/2. Okay. Now don't start. Remember how, and it's been a while, but sometimes it's easier if you simplify before you multiply. Okay? So what can I simplify here?
Those 2.
2 goes into 10. How many times?
5.
Okay, and how many times does 2 go into 2?
1.
Okay, now I'm keeping my numbers smaller, aren't I? So Bella, what's 5 times 5? 5 times 5.
25.
And 3 times 1.
3.
So now all I have to do is figure out how many times 3 goes into 25 and change this to a mixed number.
6.
8, no, and 1/3.
8. 8.
So 3 times 8 is 24, right?
Plus 1.
And 1 more makes 25, and that's what we got last time. Silly me, I could have looked at the answer. Okay, how you doing?
Good. Fine.
Let's go on. You're fine. I love it. The best problem on this whole page is the last one. It's going to prepare you the best for your assessments coming up. So here's rectangle D. I always like it when I have halves and fourths because they're easier to work with. We'll see if that's the case here. So I've got 3.5 by 2 1/4. Okay. 2 times 3. 2 times 1/2.
1/4.
2 copies of 1/2.
1/4. 1 whole.
You got it. I think you were getting ahead of me, maybe. 1/4 times 3.
3/4.
Okay. 1/4 times 1/2.
1/8.
Okay. Now, is there anything I can add up ahead of time?
6 plus 1.
6 plus 1. So I'm going to do 7 plus 3/4 plus 1/8. Common denominator.
38.
Well, you could use 32, but you'll have to simplify.
So, whatever.
8.
So we should choose 8 again, don't you think?
Yeah, I think that.
Okay, so which fraction will stay the same?
1.
1/8.
1/8. Do you know my question before I ask it? 4 times what equals 8?
2.
2.
So 3 times 2 equals,
6.
okay, ooh, this is nice. What's 6 plus 1?
7.
So,
7 and 7/8.
square units. All right, so solving this numerically, and you know numerically just means without any drawings. You know that? Okay, just numbers. So 3 times 2
6.
plus 1,
7.
2 times 4
8.
plus 1.
9.
Now, is there anything I can simplify ahead of time? Does 4 go into 7 or 2 go into 9?
No.
No. So we're going to have to multiply straight across. 7 times 9
63.
and 2 times 4.
8.
And how many times does 8 go into 63?
7.
7. And what is 8 times 7?
63.
56. 56,
Oh,
right?
60, 61, 62, 63. 7. 8.
Is that 7?
Yes.
Yes, it is, because it's 13 minus 6. Square units. You guys rock. Am I going too fast?
No. I'm actually typing.
I know, I noticed that. Okay, I'm asking if I'm going too fast, and Dusty's been ahead of me the whole time.
Same. Dusty.
I have not done that, have I ever? Called you baby?
Never called me baby.
I know. Okay, I am going to slow down a little bit, because this one's tricky. So, everybody take a deep breath. Let's slow down a little bit.
My middle name.
Let's see if you can figure this out.
It's
Okay, let me read it. A square has a perimeter of 25 inches. It has to be a square. So the perimeter is,
25 inches.
and it says what is the area of the square. Now I want you to think about this for a minute, so put your hand down for just a second, okay? A rectangle has opposite sides that are equal. Tell me what you know about a square. Isaiah?
They're the same.
They're all the same. So every single side is going to have the same measurement, okay? Now I need a problem. I don't want an answer. I need a problem so we can figure out what each side is. So Aaron, what are you thinking?
5 times 5.
Okay, you're not listening to the question. So I'm going to ask the question again. 5 times 5 would mean this had 5 sides. How many sides does a square have? How many?
4.
Okay, so it can't be 4 times 5 because that's only 20. We got to get the length plus the length plus the length plus the length. So anybody have a different idea? Okay, Angel?
25 divided by 4.
You got it. That's the problem I wanted. Is that what you were going to say? Is that what about you? He doesn't know. Okay, so I'm going to do 25 divided by 4, and I'm going to do long division because I like that little trick of how you can put your remainder on top of your divisor. So how many times does 4 go into 25?
6.
6. And 6 times 4 is?
24.
And 5 minus 4 is 1. So what do I have here?
6 and 1/4.
6 and 1/4. And that's the length of each side.
I know the answers.
25.
Well, it's not asking for the perimeter though.
Second to the area.
It's asking for the area. So we're gonna have to make a new problem. What's our problem gonna be?
6 1/4 times 6 1/4.
Okay, everybody write that down.
Times 2.
No, we don't need it times 2 because we're just doing the area. So area, what's the formula for area? Length times width. So are 2 of these I don't need, do I?
No.
Okay, so don't let that fool you. Now, this is where I'm telling you right now, sometimes it's smarter to do the area model, okay? Here's what happened in block 1. They said, can we skip the area model? And I said, sure, let's skip it. Let's just solve it numerically, okay? So I'm going to pretend I don't know, all right? So 6 times 4
24.
plus 1.
25.
So 25 fourths times
25 fourths.
25 fourths. So I'm going to have to do, there's nothing I can cross off because 4 doesn't go into 25. So I'm going to have to do 25 times 25. And that's turtle heads, so don't forget your X's and O's. Anybody want to stop and do the area model now?
Yeah.
Let's try it, okay? So the area model can be a rectangle. It doesn't have to be huge. And we're going to put how many boxes in the area model? 4. Because I'm going to separate my fractions from my whole numbers. Okay? So I want you to make sure your area model looks like this. 6 times 6.
36.
6 times 1/4.
6 or 1 1/2.
He remembered. Did you remember?
I
We were
know.
going to try and memorize that. 1 and 2/4 is 1 1/2.
I remembered better.
6 times 1/4
1 1/2
and 1/4 times 1/4.
and 8. And 8.
1/4 times 1/4.
And 8. Or 1 8. A
1/8.
1/16.
1/16.
Now, is there anything I can add together in my head?
The 1.
I could do 1 plus 1.
2. And 36 plus the 2.
36 plus 2, what's that?
38. And something else.
What else can I add in my
The
head?
2 halves.
I can add the 2 halves. So a half plus a half.
39.
So now I've got 39. And I didn't have to do turtle head multiplication.
No, you did not.
No, I did not.
This is from turtle.
So was that inches or feet?
Yeah, inches.
Okay.
Inches.
So square inches. Now, because we have 20 minutes of class left, a little more, I think we should do her turtle head just to review. Okay? So everybody, don't forget your X's and O's. 5 times 5.
25.
Shh. Are you writing this down?
Yes.
Okay. It's a good review for you. 2 times 5
10.
plus 2.
3rd. 4th.
Okay, so X's and O's. 2 times 5.
10.
2 times 2
5.
plus 1.
5.
Okay, so now here's what I know. I've got 625 divided by
16.
16. Now everybody get caught up with me. This isn't very easy. Now I got to do this problem, which is good review.
I've been doing this on my already.
Good. And it's just for practice and review, okay? But gosh, I think that area model was easy compared to this. Don't you? Okay, will 16 go into 6?
No.
No.
Will it go into 62?
Yes.
Okay. So, okay, here's what I know. I'm going to use a number close to 16 to help me figure this out. So just let me talk. Okay? What number's really close to 16? 16 that we have kind of memorized?
12.
Okay, higher.
13.
25.
That's too high.
15.
How about 15? Do we know that 2 15s makes 30?
Yes.
Plus
Yeah.
15 is 45.
So here's what I know. 15 times 3 would be 45. Okay? What do you think we should take 16 times?
16.
3.
Times 3 or 4?
3.
3? Okay, so everybody write this down. This is like guess and check, but I want it on there for a reason. Now that's only 48.
If we did
Times
another
5.
one, if
Let's
we did
try
another
the
one, it'd
fourth.
be 16.
Let's try the 4. Okay? Just try the 4 for me. I'm trying to teach you something. 6 times 4?
24.
Okay, so that's closer, but is it too big?
Yes.
All right. So we're going to use the 3. Where do I write the 3?
Above
Over
the
it.
6.
Above the
Or
2.
above the 2.
And what was 16 times 3? We already have it done. 48. And in block 1, somebody said that 2 minus 8 was 6. It is?
Or
No, it's
that's
negative.
That's negative 2.
6.
That's a negative 6.
How about we go next door? Yeah.
I don't know.
So this is going to be a 5, and that will be a 12.
Oh.
So 12 minus 8,
4.
and
We're
5
bringing down
minus
5.
4
14.
is
Bring
14 less than 16.
Yes.
Okay, I need you to stop talking to each other and listen to me. Make sure you've got all this written down. And if you need to get caught up, do it now. Now, here's what else I know. And the reason I like to write these down, boys and girls, is because they might come in handy later. So, I know 4 is going to be way too small. What if I double 4 and make it an 8? What would this 64 be?
128.
You think that's big enough?
No, yes.
Or do you want to try a 9?
No.
Okay, we're going to try a 9.
It's a 9, yeah, it is.
Okay, everybody write it down. Because if it's wrong, you're going to probably need to know what it is in the future.
Yeah, you're right.
So which one's better, the 8 or the 9?
9.
The 9. Where do I write the 9?
Above the 5.
And what do I write below 145?
144.
And I got a remainder of 1, 39, and 1/16 square inches. Which way was better that time? The area model. So here's my advice to you, okay? And we're going to get ready and do the exit ticket, but I want you to listen to one more thing. If you get started solving it numerically and you get a 3-digit divided by a 2-digit, or if you even get 2 by 2 multiplication, I would stop and see if the area model is easier before you spend all that time. Do you agree with me? Totally. What if you get started on the area model and it starts getting pretty complicated and you have to add 3 fractions? Stop and solve it numerically and see if that's easier. One of these is not better than the other. It just depends on the problem. And you probably don't remember this, but I told you area model is going to help you with one of your classes that you need when you get older. Algebra. The area model is going to help you with algebra. Okay, here's my exit ticket. You're going to need an area model. You're going to multiply everything out, and then do you remember how we added it up underneath? Everybody remember that? Okay. And then over here, You're going to solve it numerically also. Think you can handle that? And you're going to bring it to me when you're done.